Okay, this problem says assume that for all x greater than 6, it's going to be a little sketchy here. For all x greater than or equal to 6, f of x is greater than 0, is less than g of x, less than h of x. Which statement is necessary to conclude that g of x converges? So this is a generic application of the comparison test, right? So, just a reminder, like whatever f of x is doing, let's just say f of x, it doesn't really matter what they do as long as right at this instant what they're saying happens. So f of x is doing whatever, okay, and then it's like doing that. And like, g of x is doing whatever, but then eventually it's doing that. And h of x is doing whatever, and then eventually it's doing that. So in order to conclude that g of x converges, right, not that g of x converges, that the integral that we're describing converges. So like this area here under g of x, we can guarantee that sums to a finite number so long as we know that the area under h of x, right, so long as we know all of this converges. Because obviously if the area under h of x converges, then it converges to a number, and that area is all of g of x, the area under g of x plus some more. So that gives us that b would have to be true for us to converge to conclude that. Okay, so that's called the limit. It's called the comparison test for improper integrals.